Hi all. In this video, we will discuss the second two objectives. We will discuss stating the cardinality of the union and intersection formulas, and then we will find the cardinality of the union and intersection of sets. We will find the cardinality in two ways. We will do so intuitively without use of the formula, and then we will do so using the formula. Okay, so to get started, this video will start with example 3. So in example 3, you are asked to find the cardinality of A intersect B and A union B given the following sets. So let's start with A intersect B. So to find the cardinality of A intersect B, let's first list it out. So let's list out A intersect B. So A intersect B are those elements in common. So that's like 1 and 3, right? Those are the elements in common to A and B. So then we can find the cardinality of A intersect B. And how we write that is with this n, like the n of A intersect B. I think of that as the number of items in A intersect B, and there are 2 there, right? So the cardinality of A intersect B is 2. To find the cardinality of A union B, there's 2 ways you can approach that. So first we'll talk about the intuitive way without use of the formula, and then we will use the formula. So the intuitive approach is to list out the things in A union B. So A union B is those items in A or B or both. And here we will take special care to write those elements in order and only once. So I think that's all of them. 1, 2, 3, 4, 5, 7, 8, 9. Yes, those elements that are in A or B or both. So then we can simply count them to find the cardinality of A union B. And counting those, there are 8 elements in A or B or both. Okay, then we could also use the formula to find the cardinality of A union B. So with use of the formula, that says that the number of things in A or B is the cardinality of A plus the cardinality of B minus those objects that you've counted twice. So that would be the cardinality of A intersect B. So using the formula, I can plug some of these things in. Yeah, we can say that the cardinality of A is 5, the cardinality of B is 5, and the cardinality of the intersection, we found that above, is 2. So then we can say that, again, this cardinality is 8. So whether you do so intuitively or whether you do so through use of the formula, right, you notice that either way we get the cardinality of 8. Okay, we have one more example in this video. So the next example is example 4. Use the diagram displaying the cardinalities of the regions to find the cardinality of A intersect B and A union B. So in this problem, these numbers mean something different. This 6 and 4 and 2 and 12, those are not elements, but these represent the number of items in this region, the number of elements in this region, the number of elements in this region, right? So these 6, 4, 2, and 12, they have a different meaning. Okay, so to find the cardinality of A intersect B, that one's the most straightforward. That's just this region, right, is A intersect B. So there are 4 elements in A intersect B. To find the cardinality of A union B, we'll have to do a little bit more work. So to find the cardinality of A union B, again, we could approach that intuitively or through use of the formula. So intuitively, A union B, well, that's this region and this one and this one, right? Those three regions make up all elements in A or B or both. So intuitively, the number of items in A or B or both is 6 plus 4 plus 2 is 12. Okay, we can also find the cardinality of A union B through use of the formula. So let me put this up here. So using the formula, again says I can find the cardinality of A union B by finding the cardinality of A plus the cardinality of B minus the cardinality of the intersection. Okay, so here we will just have to work a little bit harder to use the formula in this example. So the cardinality of A is actually 10. You may say, well, I don't see 10 as a number on this diagram, right? But A is made up of these two regions, right? The region containing 6 elements and the region containing 4 elements. So the cardinality of A is 10. The cardinality of B is actually 6 because B contains these 4 elements and B also contains these 2 elements. So set B contains 6 items. By use of the formula, we would have to subtract the cardinality of the intersection, which is 4. So again, using this method, we'll get 12. So this should happen, whether you do so intuitively or through use of the formula. You should arrive at the same answer for the cardinality of A or B. At this point, you might say, whoa, wait a second. How come in the intuitive approach, we didn't subtract anything? Whereas in the formula, you typically subtract something, right? This is because in the intuitive approach, we only counted each element once. As long as you're careful to only count each element once, then there's no need to subtract any. And really, it's this 4 here in the middle that you're in danger of counting twice. But when we did the intuitive approach, we counted those 4 elements only once. When we used the formula, however, we counted those 4 elements as part of A, and we counted them as part of B. Now, since we counted those 4 elements twice in the formula method, we counted them as part of A and as part of B. That's why we need to go back and subtract them, right? Subtract those elements that you've counted twice. Whereas if you found that cardinality intuitively, you were careful to count each element only once. Therefore, there was no need to subtract the overlap. Okay, this completes example 4.